Continuing our videos with factoring of polynomials, we're going to start taking a look at being able to factor these sorts of perfect square binomials. Now, if we have a binomial of the form a square minus b square, then there's a pretty easy formula to factor these sorts of difference of squares, and that's going to be a plus b times a minus b. All right, so pretty easy to do that. All right. And so what we're going to do is we're just basically going to figure out what term multiplies to be a square and what term multiplies to be b square, or what term multiplies by itself to be a square, b square, right? So a really basic example, we have x squared minus 16, and we want to factor that. So we know that to get to x squared, the only thing that multiplies by itself to give you x squared is x and x. And the number that multiplies by itself to give you 16 is 4 and 4. And certainly we know that 16 is equal to 8 times 2, but they're not the exact same numbers. Okay, so whenever you're trying to factor a difference of squares, you want to make sure you get the exact same numbers that multiply to be 16. Now, if it was something like 20, okay, 20 does not have any numbers that multiply by itself to be 20. 1 and 20, 2 and 10, 4 and 5. So you couldn't factor something like x squared minus 20. All right, so this would be a prime polynomial. All right, now going back here, we just take one of the x's and one of the 4's, and we're going to use this formula to factor. So this would be x plus 4 and then x minus 4, all right? And of course, if you don't check that, or if you don't believe it, what you could do is you could just FOIL it out, all right? And that's a way to check all of these sorts of types that are binomials. In fact, let's just check it just to make sure. So we have x times x by FOILing, we have x squared, and we have x times negative 4, which is a negative 4x. Our inner terms are going to be positive 4x, and then the last terms, positive times negative 4 is negative 16. Inner terms cancel out, and we're left with x squared minus 16, which was the original binomial. All right, so that's how you can check your answers. A second example of this, 9x squared minus 36y squared. Right? So 9 is 3 and 3. 36 is 6 times 6. Right? And then we have x times x, and then we have y times y. All right. Now, before we do anything with this one, I want you to notice that there is a common factor between the 3 and the 6. All right. And so if you break these down and you notice that the two factors that multiply by themselves have a common factor, it probably means that initially in the problem, there's a greatest common factor that you have to factor out first. And isn't it true that in the beginning, both of these are divisible by 9, right? And so one of the first things that we always want to make sure of is that when we factor these types of polynomials, that we factor out a greatest common factor if necessary. All right, so we're going to put a 9 on the outside, and just like we did in the first set of videos, we're going to divide everything by 9, and that's going to leave us with x squared minus 4y squared. Right? And now what we can do is we can break things up. So we have x and x, and then 4 is 2 times 2, y squared is y times y. And so our answer, we're going to drop down the 9. We're going to have x plus 2y, and then we have x minus 2y. Right? And that's going to be our factored form. And again, to be able to get x plus and x minus 2y, we just use our formula a plus b, a minus b. One final example, we have 5x cubed minus 125xy. And so we notice that both of the first terms are divisible by 5. Both of the two terms are divisible by x. And both of the two terms that start are divisible by y. So there is a GCF that we're going to factor out, which is 5xy. In the first term, 5 and 5 cancel, y and y cancel, 3 minus 1 is going to give us an x squared. 125 divided by 5 is 25. The x's cancel and the y's cancel. And now this is pretty easy. X squared is x times x, 25 is 5 times 5. And so we can't forget the 5xy, but then we're going to be left with x plus 5 and x minus 5. And that's going to be our final factor form for that binomial difference of squares. Another type of factorization that we can perform is on trinomials, all right? And trinomials are generally the most difficult types to factor because when we go through and factor them, we have to make sure that we're good with our multiplication facts, all right? And we have to make sure that we list out a set of factors, all right? So what we're going to do is we're going to multiply the first coefficient by the last number, and we're going to list out all the factors of 8, right? So in this case, factors of 8 are 1 times 8 and 2 times 4, all right? So 8's easy because there's not too many factors. What we're going to do is we're going to add those factors together. All right? So 1 plus 8 is going to give us 9, and 2 plus 4 is going to give us 6. Now, if the two terms that factor into 8, or if the two factors of 8 add up to the middle number, right? Those are the magic numbers that we want. All right, so that's what we're looking for, is what two factors of 8 add up to 6. Right? So two factors of 8 that add to 6. That's what we're trying to figure out. Okay, and in this case, it's 2 and 4. And what we're going to do is we're going to break the problem up into a factor by grouping problem now. Okay, so we're going to hold on to the magic numbers of 2 and 4. So I'm going to erase this just to give myself a little bit more room. And what we're going to do is we're going to use those two magic numbers and split up the 6 in the middle and turn this into a factor by grouping problem. All right, that's what we did earlier in the previous video. So this now becomes x squared. We're going to drop down 6x, and we're going to make it 2x plus 4x. And then we're going to bring over the 8. Okay? And what we're going to do is we're going to group. Okay, so hopefully that makes sense so far. All right, and remember our magic numbers, 8 is 2 times 4, and we just broke up 6 into 2x plus 4x. We know that the GCF between x squared and 2x is x. The GCF between 4x and 8 is 4. So we're going to have x plus 2, 4, x plus 2. And now finally, we can write this as x plus 4 and x plus 2. All right. Just a note that for these types of trinomials where the first coefficient is 1, all right, if we get to the magic numbers, we can factor that immediately as x plus 2, x plus 4, all right, which is the answer, right? That's the same thing that we got. But if the first coefficient is anything other than 1, then we have to use this grouping method, all right? So the grouping method works for every type of trinomial, all right? This method where we just jump right to the answer, that does not work for every trinomial. It only works for ones with a coefficient of 1 in front of the x squared. Right. Now another example, we have this x squared minus 2x minus 8. So we're going to multiply, and we get a negative 8. And once we have a negative, that means we double all of the possible numbers that can multiply to be that value, because we could have negative 1 times 8, negative 2 times 4, or we can have 1 times negative 8 and 2 times negative 4. And we're going to add all these up. So we're going to get a 7 and a 2, and we're going to get a negative 7 if we add, right? And we're going to get a negative 2. And we're looking for the middle term to be negative 2, which is going to be these two factors, 2 and negative 4. All right, so this is going to, now we're going to split this up, x squared plus 2x. So we're splitting up the negative 2 using these two terms. So 2x minus 4x minus 8. And now we're going to factor by grouping. One thing to remember is that we can rewrite this as x squared plus 2x plus negative 4x minus 8. All right, so what I did was I just threw a plus sign in there. And remember the trick with the middle term so that if the third term's negative, what you want to do is factor out a negative GCF. So this would be a -4 and -4. All right. And so we're going to wind up with x plus 2, and then -4, x, -8 divided by -4 is going to be +2. And so that leaves us with the answer of x minus 4 times x plus 2. All right, and that's our final answer for this. Now, again, you could make this immediately into x plus 2, x minus 4, because the first coefficient for the x squared is a 1. But again, I'm just trying to get you all into the process of going through and using the grouping method because it works every single time. Right. So we're going to have one last video. We're going to finish up trinomials in that video. So hopefully this gives you a good introduction to both the different squares and also the trinomials, or the easier types of trinomials.